Hello, my name is Maryam Khanbaghi. I'm an assistant professor in electrical engineering at Santa Clara University. I'm also the director of Power Systems Sustainable Energy Program. So today I'm going to talk to you about building the next generation of engineers for power and energy industry. So why we are doing that? There are several reasons I want to do that. One is the increase of the population of the world, and including the US. And by increase of population means that we need more generation, more transmission line. The other reason is due to the global warming and the impact on the environment, we have an increase in power outages. The power outages mostly are due to natural disaster. And this costs US, in average, something between $25 billion to $75 billion per year. And the last thing also, which is as important, is this industry is an aging industry. In the last 30 years, it wasn't cool enough to go and work in a power company or utilities company. Now things are changing in the last 5 years. Nevertheless, majority of our experts in this area are retiring in the next 5 years. So we need to build the next generation in power and energy to satisfy the need that we have. Why Santa Clara and why what we are trying to do? We are approaching this from 3 different angles. One is, as I said, we are offering a graduate program which is a title on Power Systems Sustainable Energy Program. It's a master program that anybody with an undergrad in engineering can join the program. And it's good for people who want to change direction and change the industry. It's also good for new graduates. Then we also have Vladimir Lab. Actually, right now I am in Vladimir Lab that I am talking to you. The role of Vladimir Lab is it's open to all students in the School of Engineering and College of Art and Science, and it allows the students to explore new ideas on the renewable energies. For example, what you see here is a project, is a senior design project that student did last year, which is a mobile, a nanogrid, and then we use solar panels. Previous years, student built a nanogrid, which I will tell you a little bit later on, that they were able to present at the conferences. These are undergraduate students who work on this project during summer. So what is a nanogrid and what's a microgrid? This is the area we are doing research here at Santa Clara. How we are doing that? One thing I want to talk about what I call controlling the duct. So what is the duct? In industry, this is known as the duct curve, which is a representation of the load of California, basically. And we say that it looks like a duct. So our objective, and this belly of the duct is represented actually by the usage of solar energy. So the idea is, in order to prevent outages and keep the system stable, it make it look like a flying duck. So it's going to flatten the curve that you see here. So how we do that, there are lots of different schools of thought. And the main thing is that the challenge is that develop new technologies that allows us to control the emerging power grid, which is going to be more resilient and using renewable energies. So what we do here, we focus on microgrids. And as I kind of use it, is that resilient grid, one microgrid at a time. So what is a microgrid? Microgrid is a small energy system that balances between the generation and the load. And it uses renewable energy. And one advantage it has, when it's needed, it can connect and disconnect from the grid. For example, when there's a natural disaster, it can disconnect from the grid and still provide power to its customer. So what we are trying to do is to control the energy of an agglomeration of microgrid in order to make sure that the system is stable, renewable, and resilient.